Section 3.6 deals with related rate word problems.
So what we're doing here is looking at how different rates relate with respect to time.
So let's say that I'm given A is equal to pi r squared, which is the formula for the area of a circle. If I want to find dA dt, which means the rate of change of the area with respect to time, so what I need to do is take the derivative of both sides of this equation with respect to time. So I need to find d dt of both sides. So it works like this. So again, A is equal to pi r squared. So the derivative of A with respect to time is dA dt equals, over here, if I take the derivative, well, multiply, so that's 2 pi r raised to the first power, but we just took a derivative of an r term with respect to time. So when we're dealing with the related rates, what's basically happening is we're taking the derivatives as normal and we're including with them the d variable over dt. So whatever variable it is, r, a, h, v, whatever we have, it's going to be d, the variable, over dt. So let's look at example 1 here. Example 1 says, assume x is equal to x of t and y is equal to y of t. So x is a function where the input is time and y is a function where the input is time. Find the indicated rate given the other information. So in order to find dx dt, I first need to find the derivative of the given equation here with respect to time. So I say the derivative of x squared is 2x. And again, we just took the derivative of an x term with respect to time. Everything in this section is going to be with respect to t or respect to time. Plus the derivative of y squared is 2y. And again, we just took the derivative of a y term with respect to time. So dy dt equals, well, the derivative of 4 is 0, so we just write 0. So now it's asking us, find dx dt. So we're trying to figure out what is dx dt when dy dt is 5. So I know that this is 5. X is equal to 1.2. So I know x is equal to 1.2. And y is equal to negative 1.6. So I have enough information with all the given to find dx dt. All I need to do is plug in all of my givens and solve for dx dt. So if I do that, I get 2 times, well, x is given as 1.2. dx dt is what I'm looking for. So dx dt plus 2 times, well, y again is given. Y is given as negative 1.6 times dy dt, and dy dt is also given. dy dt is given as 5, and that equals 0. So I have enough information to solve for dx dt. So in order to solve for dx dt, I just need to work this problem out. So 2 times 1.2, I end up with 2.4 dx dt. And over here, if I multiply 2 times negative 1.6 times 5, I end up with negative 16 is equal to 0. Let's move over here. So add 16 to both sides, and I get 2.4 dx dt is equal to 16. And then finally, divide both sides by 2.4. And then dx dt is going to equal, let's grab a calculator to find that out. So if we have 16 over 2.4, it's 6 2/3. If we make that into a fraction, we get 20 over 3. So we end up with 20 over 3. So dx dt is equal to 20 over 3. So this was just a little bit of practice. What's going to be happening is that we're going to be looking at word problems. So let's kind of look at example 2 real quick and talk about what's going on here. So we're going to be looking at something like this. The radius of a sphere is increasing at a rate of 2 inches per minute. Find the rate of change in the volume when the radius is 6 inches. What's going to happen is we're going to end up with an equation kind of like this that we got right here, where I have enough givens to find the unknown. So that's what's ended up happening. We're going to have an equation, we're going to have to take the derivative of it, and then after we take the derivative, we'll be able to fill in all the information to solve for the unknown. So what are the steps to solving related rate word problems? Well, first, draw a sketch if it's helpful. If it takes you a long time to draw it, then don't do it. 2, write down in calculus notation, which is DDT, the rates you know and the rates you want to find. Step 3, write an equation that relates the variable that we know and those we're looking for. And this is sometimes the hardest part, writing that equation. Then differentiate implicitly with respect to time. And then 5, substitute your known quantities and solve for the unknown. So let's reread the problem here. The radius of a sphere is increasing at a rate of 2 inches per minute. So anytime you see the word rate, you're thinking of a derivative. Rate means the derivative. So if my radius, well, what's a good variable for radius? R. So if my radius is increasing at a rate of 2 inches per minute, then I can say dr dt is equal to 2 inches per minute. And then it says, find the rate of change in the volume. Well, rate of change in the volume, again, means derivative. So a good variable for volume is v. So we would say dv dt. So find it, which means we don't know it. And then when the radius is equal to 6 inches. So step 1, draw a sketch if it's helpful. A sketch will not be helpful in this case. Step 2, write down in calculus notation the rates you know and the rates you need to find. So the rate I know is that the radius is increasing at a rate of 2 inches per minute. The rate I need to find is the rate of change in my volume. So step 3, and again, that's the hardest. You want to write an equation that relates the variables that we know with those we're looking for. Well, since we're talking about volume of a sphere, the volume of a sphere, that formula is my volume is equal to 4/3 pi r cubed. We have an equation that relates V and R, which is perfect because that's what we need. Because when we take the derivative of this guy, we're going to have a dv dt and a dr dt, and that's what I'm looking for. So now, step 4, differentiate this guy with respect to time. So the derivative of V is dv dt. For here, the derivative of 4/3 pi r cubed, well, if I multiply 4/3 times 3, that's 4 pi r raised to 1 power less, which is squared. And I just took the derivative of an r term with respect to t. So now, do I have enough information to solve for dv dt? Let's see. So this is what I'm looking for, dv dt. 4 pi is a number, 4 is a number. R, do I know what R is? Yep, I was given that R is equal to 6 inches, so I have this. And do I know the rate of change of my radius? Yeah, I'm given that dr dt is equal to 2 inches per minute. So I have enough information to solve for dv dt. So dv dt is equal to 4 pi times 6 squared times 2. So I need to figure out what 4 times 6 squared times 2 is. So on a calculator, 4 times 6 squared, or 36, times 2 is going to be 288. So dv dt is equal to 288 pi inches cubed per minute. Or if we want this as a decimal, well, we would just take 288 and we'd multiply it by pi. So you're just going to multiply it by pi, which is right there beneath that clear button. And then we end up with, to one decimal place, 904.8. So it would be approximately 904.8 inches cubed per minute. Let's look at example 3. Example 3 says, a point is moving on the graph of 4x squared plus 9y squared equals 36. When the point is at 3, 0, its y-coordinate is decreasing by 2 units per second. Well, we just got some kind of calculus rate, right? So its y coordinate is decreasing by 2 units per second. Well, what does that mean for us? That means that dy dt is decreasing, so negative 2 units per second. So then it says, how fast is the x-coordinate changing at that moment? So how fast is the x-coordinate changing means what is dx dt? Again, a graph for this one's not going to really help us. So I already have step 3. I already have the equation, so that's my step 3, which is great. There's no work to be done there. And then I'm given what my x and my y are, so I have enough information to get going on this problem. So I'm given the equation, 4x squared plus 9y squared equals 36. So I have to start by taking the derivative of this equation. So the derivative of 4x squared is 8x dx dt. The derivative of 9y squared is 18y dy dt. The derivative of 36 is 0. Do I have enough information to solve for dx dt? I sure do. I'm told that x is equal to 3. I'm looking for my dx dt. I don't know what that is. Plus 18. I'm told that my y is equal to 0 and that my dy dt was at negative 2 units per second. And that equals 0. So if I continue on here, this is going to be 24 dx dt. And if I multiply here, 18 times 0 times negative 2, well, anything times 0 is 0 equals 0. So we have 24 dx dt is equal to 0. Solve for dx dt. And I get dx dt is equal to 0. So what does that mean? It means that my x coordinate is not changing at that moment. And why is it not changing at that moment? Because the rate of change is 0, so it's not changing at that moment.